let's talk about Meadow Foundation. For the people who doesn't know what Meadow Foundation is, it's all about building a plug and play developing or building experience. It's all about just we want to just try to keep you away from data sheets and of components that you will have to spend time to write your drivers and see which pins they have to go high and low. We want to move you away from that and try to get you more time focused building your solution rather than building the parts that involves to make your solution. So right now I also split this into 5 sections: building plug and play, building experience. Super cool. It's actually what I showed you on my little rotation detector sensor. It'll be just about telling it on which pins you are connected, and you already have a set of APIs ready to go. We have over 100 available peripherals already in the NuGet gallery. Obviously, we don't want to cram all those 100 peripherals in a single library and then try to just use a small percentage of them. So if we go, say, to the NuGet gallery here, and let's see, I can search for Meadow Foundation. There we go. We have 100 exactly packages readily available. You can see you already have almost 27,000 downloads on Meadow Foundation, because Meadow Foundation core comes already with a set of very simple drivers, such as LEDs, rotors, rotary encoders, things like that. And then what we want to do is, when we want to add more specialized peripherals, you can just download them separately and add them to your project. So in this case, for the Klima Hackit project, which I have right here, let me switch to Klima solution right here. Let me bring up my little camera. So for the Klima project, we already have a set of NuGet packages installed. So let's go, and we see things like we have our Meadow Foundation project, which is the core library for things, again, as like doing basic things like the analog temperature sensor, the push buttons. We have a text display menu. It's something that it's a little library that helps us to interact with the buttons to switch, in this case, the units of the climate for Celsius and Fahrenheit. We have the TFT SPI. This is for our displays. So we have the display right here. This is the one that comes in the Hackit, and a simple JPEG decoder. It's, again, this is full.net, so you are able to just download almost any NuGet package that is out there, even system.txt.json, to serialize just like you would do on any mobile or desktop app, and you can just use it right there on using Meadow. So let me show you here in the Meadow app. We have an initialize method of how to initialize. We have an LED indicator. We pass in the device, in this case, Meadow V1. How Chris Taggy said earlier, paradigm for Meadow app is passing what device are you working with, especially now that we are adding Raspberry Pi into the mix. It's very important, this field here where you're telling, okay, what device am I running this application? In this case, it's an F7 Micro. And then we pass in things like the device to create an LED indicator, which is the onboard LED. And then we have an analog temperature sensor. And here we pass in which pin is connected. Again, we're passing the pin analog 0, which is right here, the blue line here. And Meadow Foundation say, okay, there's many different analog temperature sensors. Which ones are we talking about? In this case, we go back to the Hackit version. The Hackit temperature sensor we have is the LM35. And we have a display controller. So we want to abstract these peripherals into making them like more bite-sized, more and abstract all the logic of them. So display controller has even its own initialized method, and is basically just doing the same thing. It's an ST7789. The display that we have is a 240 by 240 resolution display, and we pass in all the necessary parameters so we can get started talking to it with using Meadow. And another cool thing that we have on Meadow Foundation is graphics library. So graphics library is something that we built in-house, and it's a driver that is display agnostic, meaning that whenever you create an object of a display, regardless of the nature that the display is, when you pass in that object to graphics display, now you can start doing things like drawing shapes, like circles, rectangles, drawing text, drawing images, and you can do all that using graphics. And if you swap your display with another one, you just simply have to specify resolution and what type of display it is, and graphics library will just keep running and just redraw everything based on the new hardware of the display that you're running there. So super exciting stuff. Let's go back here. Unitization, that's a big one. That's something that we also meant to cover in our platform, is using units. We have a lot of sensors out there. We have load cell sensors for weight. We have distance sensors, but we don't want to say things like, oh, values are going to be from 0 to 1 or 0 to 1024. We wanted to actually give meaningful values for the user. And so we make sure that we're all on the same page. Like, are we going to work with Celsius? Are we going to work with Fahrenheit? We're working with Kelvin if it's a temperature sensor in this case. So let me show you a quick glance about how we're working with the units. So after we have our analog temperature sensor here, if we go here and we read the conditions, notice that we're doing a display controller, and we're passing in update the display to update the ambient or the room temperature. So let's go here. Let's go dive to the, and then here on the render method, this is where I wanted to get and to show you. So we have a Boolean here that says if it's Celsius. We have our conditions, that is the value that is brought up by reading the analog temperature sensor, and we already have Celsius, and already in-house it's giving you units. So you have Celsius, we have Fahrenheit, we have Kelvin for all the scientists out there, and we'll plan to keep adding more if necessary, or you guys can, all this is all open source, so if you guys want to add a new unit on temperature or any other metric that we want to send, we'd like to hear about it. And so, yeah, that's something that is really big, really important. We also have microservers when we are rotating back and forth. Are we talking about radians? Are we talking about regular degrees? Super, super important. Amazing API docs. This is also really important. We need to, our drivers are always not ready for production if they don't come hand in hand with docs, because it doesn't matter if I release the driver for a ST7789, people are not going to know how to use it until they see an example. So if I look for a display, we have the TFT SPI driver here. We have great API docs with already links to the GitHub repo to show you the source code of how the driver was written. We also showed you a link of where the NuGet packages are stored and which ones do you need to use in order to add them to your project. And there's a basic, blurb about what peripherals are we including in this package. Since they're all about the same nature, the TFT SPI drivers, we have a set of other displays here available and ready to use. So if we go to the ST7789, we already have super important, usage example. So it shows you right out the gate how are you supposed to use it. And this is now, all these code snippets are on B6. They are going to be fully updated automatically. We automate the way of our code snippet samples to update in every release. So no more about like getting old samples and not being able to run them because they were updated docs. These are copy paste, and you'll get your peripheral or your example running right out the gate. And this has to come, of course, with a Fritzing diagram to give you a look of how we're wiring, in this case, the display into your board. So first step, you grab your display, you connect everything, you make sure, double check your connections, and finally run your example here, and you should be good to go and really start tweaking and start getting going on building your .NET up there, .NET Meadow application. And the last point I wanted to give is that all this is open source. So if you go back here, we have, okay, that's not good. GitHub.com labs, and we have our Meadow Foundation repo, where we have all the documentations, we have public contributions for sensors, we have sensors requests or just peripheral requests of people asking, hey, I got this display, right now I can't find it, can somebody work on it? So you'll just create an issue, and we can, or anybody in the public can also take a look, or people can also just bring their inventions of peripherals and add them into our Meadow Foundation repo.